So for number 23, you first want to get the equation equal to 0. Okay, so you first want to get rid of the minus 4r by going plus 4r. That'll cancel it out. And then you're also going to add 4r to this side, which you could actually do with the minus 21r. So on the left side, you're going to have 10r squared minus 17r equals 6. And then we're also going to get rid of the 6 by subtracting 6. That'll cancel it out. You will get an equation equal to 0. And once you have that equation, what we're going to do is try to factor out a GCF, but there's nothing to possibly pull out. There's nothing in common. So we are going to have to jump to the multi-step process. Step 1, multiplying a times c, and that's going to be negative 60. So you got to now think of the multiples of negative 60 that combine together to give you negative 17. So let me just make a list of how to get negative 60. So there's a list of all your possible ways of getting negative 60. And which pair of numbers combines together to give you negative 17?
3 and negative 20.
5 and 12.
So if you think about, this jumps out at everybody, right? But if you add negative 5 and 12, that actual answer is 7, not negative 17. So you don't even have the right numbers. But when you go negative 3 and 20, that really does give you 17 when you combine them together. And you have the right number 17, but you just have the wrong signs. So change both signs. Instead of a minus, it's going to be a plus. And instead of a positive 20, it's going to be a minus 20. So those are your correct pair of numbers. Step 3 is to rewrite your quadratic equation. But instead of 3 terms, you're going to make it 4 terms. There it is, 4 terms instead of 3 terms. After all, 3r minus 20r is negative 17r. So it's the same exact equation. Now let me focus in on this 4-term equation, and let me ignore the equal 0 right now. Let me factor by grouping. So what could I pull out of my first group? An r. And if I pull out an r, what's going to be left? 10r plus 3. Okay? And in the second group, what could I pull out? What could I pull out of the second group? What's in common in the negative 20 and negative 6? A 2. But you see how in here we have positive values, and over here we have negative values. Let's pull out a negative 2. Pull out a minus 2. That way you'll end up with positive 10r plus 3 also, the same exact binomial. So now what we're going to do is take a step back and pull out the common binomial that's in both terms. I want to take this 10r plus 3 and this 10r plus 3 and put it out here in the front. So if you pull out the 10r plus 3 out here, the r is left over and the minus 2 is left over. Again, the r is left over and also the minus 2 is left over. So there's your factored form. This binomial 10r plus 3 times the binomial r minus 2. That's your factored form. Now remember, this was an equation. So this equation at the beginning was set, we set it equal to 0. So we still need to set it equal to 0 and then apply the 0 product property. So if we set it equal to 0, we're going to split it and solve. We're going to have 10r plus 3 equals 0 and r minus 2 equals 0. On the left equation, the blue one, if we add or subtract 3 on both sides, we're going to get 10r equals negative 3. And if we divide both sides by 10, we're going to get the answer negative 3/10. So the tenths cancel, r equals negative 3/10. That's one answer. Now the other one, you're going to add 2 to both sides, and you get r equals 2. It's your other answer. So we get 2 answers for this problem. It's a lot of work. There will be a handful of these guys. But on the quiz tomorrow, there's going to be a lot where you could use a shortcut. Now what do I mean by shortcut? Where you just have something like x squared minus 5x minus x, and you could just jump to the shortcut because the a value is 1. You could jump to the shortcut. You don't have to do a long step process because x squared is easily done by x times x. Now what pair of numbers, what belongs in the parentheses here for this shortcut? What times what is negative 6 that if you add it together is negative 5?
times 1.
Negative 6 times positive 1. A lot of us are thinking 2 times 3, right? But if you add the negative 2 and the positive 3, or the negative 3 and the positive 2, it will not give you the middle value, negative 5. So it is negative 6 and 1. That's a shortcut. There's going to be a lot of these guys on tomorrow's quiz, which is multiple choice, by the way. But the hardest type of question that you're going to see on tomorrow's quiz are going to be the ones that are right here in the worksheet for today's homework, like these. Should we try another one of these? Which one? Should we try 26? 26 is not equal to 0, so let's move everything to one side. I'm going to move the minus 6z by adding 6z, and I'm also going to subtract 15. So I'm going to add 6z to both sides, and I'm also going to minus 15 to both sides. So here's technically my quadratic trinomial, and it will be equal to 0 because everything canceled out on the right side. So let me rewrite this thing. You understand what I did right there? I moved everything to the left. Now it's equal to 0. Now if we look at our three terms, should I go 9 times 15 and start the process? No, why not?
You can put 3.
You could pull out 3. Good job, Mario. Paying attention. I like it. So let's put a 3 on the outside. And what's going to be left on the inside? 3z squared plus 2z minus 5. Now, because this is an equation, because it is equal to 0, then technically you could divide this whole side by 3, which cancels it out, and divide this whole side by 3, and 0 divided by 3 is still 3. So in reality, you just have the quadratic trinomial 3z squared plus 2z minus 5 equals 0. And now we could jump to the long process of multiplying a times c and all that good stuff. So let's go for step 1, a times c. A times c is what? Negative 15. Come on, guys.
Negative 15.
Step 2, make a list of the possible multiples of negative 15 that combine together to give you 2. That's the only way you could get negative 15. Negative 1 times 15 or negative 3 times 5. Now, which pair of numbers combines together to give you the middle value b? Negative 3 and 5. And you don't have to change any signs because if you really combine the negative 3 and the positive 5, it really does give you a positive 2. So we're good. So step 3 is to rewrite your quadratic trinomial as a quadratic polynomial. 4 terms. So you're going to have the 3z squared, this 3z squared, you're going to have it, but the 2z, you're going to write it as 2 terms. Instead of 2z, it's going to be negative 3z plus 5z. So notice that I left some space between the two groups because I want to factor by grouping. In the first group, what could I pull out? What's in common? Not just the z, but also, what could I pull out of that first group? 3z. 3z. And what would be left on the inside? A z. What else? Minus 1. Now let's take a look at the second group. There's a 5 in both of them, so let's pull out a positive 5. By the way, this is a z, not a 2. So let's pull out a positive 5. So there's a plus 5 that I'm pulling out. And what's left? Z minus 1. So now I'm going to pull out that binomial z minus 1 from both groups and put it out here. So if I pull out the z minus 1 out here, I'm going to have a 3z left over and a plus 5 left over. Now, remember that this is... Sorry about that. Remember, this is an equation that's set equal to 0, so we're going to have to still set it equal to 0, but now it's in factored form, which means that we could apply the zero product property and split them and solve. So we're going to have z minus 1 equals 0, and we're also going to have 3z plus 5 equals 0. So our final answers, if we add 1 to both sides, you're going to have z equals 1. And over here, minus 5, you're going to have 3z equals negative 5. You're going to have to divide by 3, So Z is going to equal negative 5/3 as the other answer.